All right, folks, welcome. We'll get started here in just a minute. Please take a moment to enter your name and the name of your firm into the chat so that our presenter today can see who's in attendance. And folks, as you sign in, don't forget to put your name and the name of your firm into the chat so that our presenters can see who's in attendance today. We'll get started in just a minute. All right, we're gonna hop into it. I know that our presenter has a lot to share with you today, so we'll go ahead and get started here. A note up top about the guidelines for this webinar. You are all in attendee mode, so you will be muted, but please feel free to use the Q&A function to enter in any questions for our presenter. We will be recording this webinar today and making it available on our YouTube later so that you can review anything that you might have missed over the course of the webinar. And please keep in mind that we are a small team, so we can't necessarily troubleshoot for you if you have any internet connectivity issues. But you should be able to log in using through your phone and attend the webinar by calling in through the number that you received in your email confirmation this morning if you need to. On the agenda for today, we'll be hearing about flooring and healthcare outcomes and evidence-based design overview. We'll have a very short Q&A at the end and close out with some upcoming AIA events that we've got coming up for you. Our presenter today is Paul McKinney. Paul's 30-year career in the flooring industry has largely focused on healthcare. Paul's passion has always been led by a focus on the ability of the floor to affect outcomes in the built environment. He was an early adopter to the concept of evidence-based design, earning EDAC accreditation in 2010. Paul has been a speaker at HFSE, Healthcare Facility Symposiums and Expo, and MetroCon Dallas. In 2020, he developed a CEU course on the many aspects of flooring as it relates to evidence-based design, with a focus on the role of floor's ability to affect three types of outcomes: clinical, operational, and the business case. He has both participated in and led teams that have successfully contributed to some of the largest projects and standardization initiatives in the healthcare construction industry in the last 15 years. Paul is the recipient of the Dale Carnegie Highest Award for Achievement and has held accreditation as a certified safety auditor through the National Floor Safety Institute. He is a graduate of the University of Wisconsin-Madison and enjoys playing music in his free time. All right, we'll hand it over to you, Paul. Thank you so much.
Thanks, Erin. Hi, everybody. Nice to be with you. Thanks for joining. I like to have my camera on just to say hi and now put a name to a face, but I'm going to turn my camera off now for the presentation, so I'll come back at the end. Like Erin said, shoot any Q&A. I get going and get pretty into it, so if I miss your question, I'll try to keep an eye on it, but I'll also present my contact info, email, phone number. Please let me know if you want to carry on the conversation subsequent to our presentation today. So I will stop my video and share my screen, and we'll get going. And if all the machines are working with each other, you should be seeing my screen right now. So this is a CEU by the title of Flooring and Healthcare Outcomes and Evidence-Based Design Overview. I'm in full screen mode, so again, oh, there we go. I can see the Q&A screen now. This is a fully accredited CEU program, qualifying for 1 AIA credit hour, health, safety, and welfare. It also qualifies for 2 IDCEC hours and 2 hours through the Center for Health Design and their EDAC, Evidence-Based Design Accreditation Certification Program. So as far as your AIA credits, please get us your number. We will report and get you a certificate. Same with IDCEC. If it's an EDAC credit, when you go to re-up your accreditation through Scantron, you self-report. So there won't be any reporting done by us relative to Evidence-Based Design Accreditation Certification. That's me. That's my cell phone number and my email. Please make note of it. I talk really fast. There's a ton of stuff to get through, but even despite that, I'll probably be right up against the hour when we're done with the content. And I don't want to keep anybody over time. I'm really sensitive to your schedule. So if we run out of time, but you have things you want to talk about, please reach out to me directly and we can answer questions or clarify any information. Okay. So as is the case with any CEU, we have some learning objectives. And after completing this course, you will be able to identify the 3 types of healthcare outcomes. You'll be able to understand the difference, importantly, between empirical evidence and rational inference. You'll be able to look at aspects of flooring that can positively affect desired outcomes and select the proper flooring for a given application. So what I like to do before we launch into the content itself is do a brief overview of evidence-based design in general. I think it helps to put some framework or some context around this argument for people who aren't as familiar. So if we have anybody in the audience who already has your EDAC accreditation or is intimately familiar with evidence-based design, I apologize. This may be some review or some redundancy, but for those of you who are less familiar with it, I think it does provide more of a foundation for everything we're going to talk about going forward. So it'll take about 5 minutes, and thanks for your patience as we go through this. So evidence-based design is derived from evidence-based medicine. And obviously evidence-based medicine is very stringent, very rigorous. We see that in our quest now, even for a vaccine, that clinical trials have to happen, journal articles have to be written, peer-reviewed, published. The standard for a procedure or a drug to be used on a patient is very, very high in terms of the cause and effect, or A plus B equals C. Evidence-based design strives for that same level of rigor, but it often doesn't achieve it. So in those cases, we're left with relying on the best available data, evidence, and post-occupancy evaluation process to inform our decisions about the built environment. So very, very early on, it's very clear that we need to recognize what we can do, what we can't do, what we're trying to achieve, what we can't achieve, and be very transparent about where those gaps exist, so people don't get the impression that we're trying to greenwash, to borrow a term from sustainability, evidence-based design, okay? So that's some of the similarities and differences. The Center for Health Design defines evidence-based design as the process of basing decisions about the built environment on credible research to achieve the best possible outcomes. Okay, so again, we then revisit this term rational inference. That's the term evidence-based design uses to use the best available data, evidence, and POE in order to inform our decisions when we don't have that rock solid cause and effect data. So a little bit of the history of evidence-based design. Going back as far as ancient Greece, healers really got the notion that the built environment could affect clinical outcomes. So as a result, they oriented patient recovery areas to face the sun, believing anecdotally that did affect healing outcomes. We fast forward to 1984, and Roger Ulrich, who's largely considered the father of evidence-based design, did a seminal groundbreaking study in which they set up the controlled experiment for a view of nature, trees and grass versus a view of a brick wall. And they saw demonstrable outcomes in the outcomes relative to fewer pain meds required, shorter hospital stays, fewer negative evaluations in their Press-Ganey scores. So that was really a groundbreaking study that inextricably linked the built environment, as we call it, to those outcomes we're trying to achieve. 1996, evidence-based medicine was defined, and in 2003, we defined EBD. So before we launch and kind of look at this thing, I like to look at what I call a couple of gold standard impacts of EBD. When this works perfectly and there is that kind of cause and effect, what are some examples of that happening in our industry? One of those is Bronson Hospital in Kalamazoo, Michigan. They switched from semi-private rooms to private rooms, and that led to a demonstrable, actually an 11% reduction in nosocomial infections. So that's a huge intervention directly leading to an outcome improvement. Similarly, Peace Health in Oregon installed patient lifts, and that led to a demonstrable reduction in staff injuries. So those are two great examples where the data and the POE actually supported the design intervention. So again, not to beat it too dead, but we really do constantly look at that empirical data versus rational inference and where gaps exist, what we can do to credibly implement a evidence-based design strategy. So you as architects, designers, and users have a lot more things to look at if you employ an evidence-based design strategy than I, as a flooring guy, do. There are certain things in flooring, 7, 8, 9 different things that can contribute to the conversation. But at last count, I think I identified 75 or 80 things that you may employ in your evidence-based design strategy. Might include things like acuity adaptable rooms, or patient lifts, or nurse station configuration, the old racetrack versus pod design, use of acoustic materials. All these different things are things you may choose to look at in your visioning strategies relative to a project. In terms of establishing the relevance of the topic itself, I kind of like to ask this question. If I were in a room with all of you, I would ask this, and everybody throw out guesses. And if anybody were close or got it, I'd probably have a Starbucks gift card for you. So using the honor system, if you get this close or right, let me know, and I'll hook you up with a Starbucks gift card. But all kidding aside, you know, we fight the perception of some evidence-based design skeptics out there. And I'm very, very empathetic to that, because again, we don't want to oversell or greenwash anything. And there are some evidence-based design skeptics. So even within my own organization, in saying, hey, is evidence-based design a relevant topic, or is it just some esoteric thing that I've concocted to try to, you know, make us sound smart and differentiate? And it's really exciting to note that 71% of all healthcare design professionals say they use evidence-based design. So as in terms of a topic and a strategy, it is indeed relevant to what's going on in healthcare design today. Similarly, the military health system has a complex evidence-based design checklist for developing world-class healthcare projects. Okay, so that concludes my, my brief intro. As we get into this, the first learning objective was we're going to look at 3 types of outcomes, and everything we talk about will relate back to these 3 types of outcomes. And those types of outcomes are clinical. Can what we're doing in the built environment actually help to make people healthier? Not only patients, but also improve outcomes for staff and even visitors as well. And from, you know, again, a personal standpoint, being a flooring guy and thinking that what we can do can actually help make people healthier is a pretty cool thing. We look at operational outcomes. Can what we're doing from an operational standpoint in terms of a variety of things, full-time employee hours and efficiency, EVS protocols and efficiency, reducing cost and complexity relative to all areas of our operations. Maybe it's supply chain and purchasing, maybe it's our lean IPD initiatives. All the different areas where operations enter into it, can we affect those outcomes with what we're doing? And finally, the business case. Things that we put into the hospital must, based on an evidence-based design strict definition, prove an ROI. They must pay for themselves. We can have the most Taj Mahal, gorgeous, gold-plated hospital in the world, but if it doesn't literally pay for itself over time and make the business case, it can't literally be considered an evidence-based design intervention. So those 3 types of outcomes are critical to the whole EBD story. And as we go through the modules, we'll relate those back, okay? So without further ado, this CEU involves 6 different modules. There's a lot of content in each one, and there's no way we can get through all 6 in 1 hour. So we pick 3 modules and go through them. I usually poll the group, and in this case, it was determined that we're gonna look at number 2, durability. We're gonna look at number 3, reducing complexity, and number 4, infection control. You'll earn all your CEUs by virtue of what we do today, so there's no issue with that. But if you like the content and the format and you want to see the modules on aesthetics, maintenance, or human health impacts, please let me know, or let AIA know, and we will certainly come back and do it either individually for you or as a group again, knowing that we can't double dip on the CEUs. Your CEUs will be earned today. If you want to see the other modules, it'll just be for fun. Okay. So let's look at number 2, durability. We're going to look at load ratings. We're going to look at maintenance protocols as they relate to durability. We're going to look at surface density and porosity. We're going to look at weld integrity, and we're going to look at life cycle costs. So it's important to note that you as architects and designers and we as manufacturers have gotten this question. You'll ask it, we'll try to answer it. You'll say, hey, what's your PSI? And people will be like, well, give us your PSI. And I get it. It's a ostensibly a way to get an apples to apples comparison of 2 different products. A higher PSI ostensibly means a product's going to be more durable in their critical areas of durability. The problem with PSI is that the way it's typically measured and communicated is through this ASTM F970 reading. The problem with F970 is that it's a very low threshold. It's about 250. And your average manufacturer's rep is paranoid at the notion of reporting back a strict ASTM F970 number of 250. And you as architects and designers won't see any value in it because it provides absolutely no differentiation. It's such a low threshold that everybody hits it. So what you'll see is quite typically ASTM F970 with an asterisk after it. And what that asterisk means is that the test has been modified. And so you'll see a modified number of 1,500, 2,000, 3,000, whatever the manufacturer wants to report is what that number will read. So unfortunately, it's become a situation where manufacturers are in essence making up their own tests. They're making up their own ASTM F970 modifications and reporting those numbers, which manifests itself in a reality that you have zero ability to have an apples to apples comparison. One manufacturer might decide, hey, we're just going to add raw weight to the initial standard and figure out where the floor starts indenting, and that's our number. That's a pretty valid modification. Other manufacturers might go, okay, the test is based on 1 wheel, and at 1 wheel we have 500, but let's make it for 4 wheels because a typical piece of equipment has 4 wheels. We're going to show the reading for 4 wheels. Now all of a sudden we're at 2,000. That literally has been done in our industry. So unfortunately, there's a lot of snake oil being sold around F970 and PSI, and best practices these days would really dictate that we get away from that whole question and answer of PSI as a valid determinant of durability. There are better ways to compare durability. So as a result, PSI can be confusing, doesn't reflect a floor's real world ability to handle rolling and point loads. Best determinant of durability and predictive performance is company history in a given application and stakeholder feedback. Benchmarking, referencing, talking to your peers, figuring out, hey, your ORs are like ours. You have your Skytron or your Steris Amsco tables with the hydraulic locking feet, and they're brutalizing these floors day in, day out. What made you switch? What are you using? What failed in the past? That benchmarking and that reference seeking is critical in terms of durability. Similarly, mock-ups are a very valid evidence-based design vehicle for vetting products that have not been previously used. If you think about it, you might have a product that's successfully performing like the picture on the left under pallet jacks and forklifts from a durability standpoint, or in a brutal operating room or a bariatric application that may have a lower PSI rating just because the modification hasn't been done like a competing product, or they didn't modify it at all. So that's a little bit on load ratings, and hopefully that makes sense. We look at maintenance protocols. There's a whole nother module in this CEU on maintenance. We're not doing that one today, but the bottom line is that the durability of the product and the way a product is made has everything to do with maintenance. That's why maintenance is part of the durability module, because they are really closely linked. You see that picture on the right, that's from one of my gallery of flooring horrors. That is a floor that could be scrubbed, could be maintained, could be restored, could be shined and cleaned up to look great. but the nature of the product is such that it grabs dirt more aggressively. It grabs the shoe scuffs. It scratches a little bit more easily because of the durability features, such that it looks dirtier between scrubbing. And our EVS people, they're on defense. They're fighting every day for the perception of cleanliness. It's key to your HCAP scores. It's key to perception. It's key to stakeholder feedback and morale. And the notion that EVS people will have to scrub the floor every day or constantly to keep it looking great is a real challenge. So the notion of a durable floor should be that with just a microfiber or a wet mop, they should at least be able to keep it looking good between scrubbings, such that the perception of cleanliness and all the other outcomes that are derived from that are realized. Okay? So surface density in construction is the largest determinant of overall durability, long-term performance as it relates to maintenance and everything else. Products requiring highly specialized cleaning equipment and protocols can negatively impact operations. Your floor should be able to be cleaned and maintained with things that are currently in your EVS closet. You shouldn't need proprietary equipment, special pads, multiple machines, and multiple steps, which a lot of floors may require in order to keep them looking good. So products, again, with a durable, impermeable surface can be more easily cleaned between scrubbings. So we look a little further at surface density and porosity. Floors with best-in-class density will resist staining from common healthcare chemicals and even harsh disinfectants and other materials that are being used more commonly today. How this goes is like this. Maybe you've had a rep in there and they have a sample and they stain it with some betadine and rub it off and go, hey, look at how great our stuff performs. And that may be fine and well. That may be a good little in-person demo. But ASTM actually has a protocol and a standard by which floors should be stained, the amount of time the staining agent stays on the floor, and how it's cleaned. And those results in that protocol should be able to be shared with you through a published document such that the ASTM protocol is maintained for repeatability and predictability. And frankly, it's not just betadine anymore. Betadine's pretty easy. We all have seen betadine stain floors over the history and clean it. But we know now that in your interventional radiology suites or your ORs, the betadine and the iodine that's used for skin prep has been replaced in certain cases with things like chlorhexidine, ChloraPrep, because of iodine allergies. And chlorhexidine is a harsher staining agent. So not just being able to do a little betadine demo, that doesn't cut it anymore. You've got to be able to demonstrably show that without ever waxing or stripping a floor, your floor will be permanently resistant to all the chemicals in your facility. Not just betadine and iodine, it's got to be chlorhexidine, it's got to be DuraPrep, it's got to be eosin, benzoin, methyl blue, IV dye contrast. The list is voluminous, and the durability of a floor should be such that the floor is permanently stain resistant without ever having to strip and wax. We look at weld integrity. Of all the slides in this module, and maybe even the whole presentation, this, I think, speaks to all three areas of outcomes better than anything else. Looking back, we are looking at clinical outcomes, operational outcomes, and business outcomes. Here's another couple of pictures from my gallery of flooring horrors. These are things that should never happen to your floors, but they do unfortunately happen all too often. It's to the point where seam weld integrity is one of the most important factors in sheet good durability. It's talked about constantly. I'm in way too many meetings, not necessarily because of our floor, just historically as a flooring contractor and working for different companies over 20 to 30 years, where bubbles and seam breaks are way too prevalent. So the first thing is to acknowledge it's an issue, say that stakeholders are troubled by this. It's to the point where some of you might even be reverting back to epoxy or terrazzo floors because you've had problems with resilient floors. You've had one too many seam breaks, one too many bubbles, and you throw up your hands and go, I'm done. I'm going back to epoxy and terrazzo because my resilient floors just can't handle the abuse in the ORs. And we're very empathetic to that. But what you have to realize is this: what are you sacrificing? You're sacrificing comfort, cleanability, repairability, cost. These stone floors are very hard, are very expensive, hard to repair. And even though terrazzo is a very hard surface, it is porous. It can stain with some of those staining agents. So the notion that you have to give up all this to get a resilient floor to perform is where we take exception. And we're kind of going on offense and saying, we hear, we acknowledge, but there is light at the end of the tunnel. It's very, very important to realize the installation component of this is critical. That floor must be grooved. Every weld must be grooved to the proper depth before it gets refilled with the welding rod, with the seaming agent. So the grooving of the floor at the proper depth is critical to the ultimate performance of the seam. The welding gun must be at the proper temperature and speed for that weld to be created with integrity. So through installer training and installer expertise and proper fabrication of seams, that's a big deal. But even when that happens, all floors are not created equal. There is a EN standard 684 that actually shows in newtons of force required to pull two welded pieces of material apart, that all resilient floors are not created equal. Some sheet vinyls, not to mention rubber and linoleum, do exhibit stronger seams when they're properly exhibited. So again, this is a big deal. Seams should perform, they can perform, and they will perform when enough attention is paid to all these different details. Oh, going back to this, to relate it back to the clinical, operational, and business case, I think a lot of this story tells itself. Obviously, from a clinical standpoint, if bacteria, mold, pathogens harbor in those broken seams, that's a big deal. God forbid it turns into an HAI event that has absolutely clinical ramifications. From an operational standpoint, we've all sat in a room where everybody's sitting around trying to figure out why this happened and how we get it to not happen again, from facility managers to engineers to maybe a designer, maybe a perioperative nurse manager, an infection control expert, a GC, a flooring contractor, a vendor. We're all sitting around figuring out how to fix this thing that's operationally suboptimal. Then when it comes repair day, we're getting in the bunny suits at 5 a.m. and going in and putting up the HEPA filtration and the containment and shutting the space down. So it's clear that operationally this suboptimizes outcomes. And then the business case obviously is affected too. Again, in the instance of an HAI event, the business case is tremendously suboptimized, but even the cost of shutting down a space and of all the people having to sit around figure out how to fix this and then fixing it operationally, there are better things to be doing. So again, that kind of relates back to those three areas of outcomes. So to wrap up this module, we look at life cycle costs. Everybody wants to know from an ROI standpoint, life cycle data. The problem is that everybody in the industry has their own life cycle cost chart and story, and lo and behold, everybody's chart shows that their stuff's the best and the most cost effective. So the notion of a third-party peer-reviewed dynamic life cycle cost study is of value. Most life cycle cost studies are static. They involve maybe 15 years of looking at different materials, vinyl versus rubber versus LVT versus VCT versus cork, and looking at typical first installation costs, maintenance costs, repair, and coming up with a 15-year cost. And those aren't bad. We've all used them and they have value. But the Journal of Hospital Administration has actually published a real-time case study findings. It looks at real-time data like, hey, are you stripping and waxing every 2 years versus once every 6 months? Are you using a 20-inch pad on your scrubber versus a 14-inch pad? Are you using a 28-inch dust mop versus 14-inch? These real-time factors do factor into the real-time ROI of a floor. So when you look at the data reported by this third-party peer-reviewed published study, it does show that sheet vinyl with a factory-applied coating that sustains to date does provide the best ROI. Now, there's a lot in that last sentence in terms of sustaining to date. Let's look at column 4. There are some rubber products that purport to perform better because they don't have any coating at all. They come uncoated. And we'll look at some of that going forward. But the story is that sheet vinyls with factory applied coatings, those coatings will wear off, they'll go away, they'll get damaged, and eventually your no wax floor that was promised to be no wax, you're all of a sudden back into a stripping and waxing regimen. And that's a real phenomenon. It's almost like a heartbreaking bait and switch. You thought you were buying a no wax floor, now you're waxing it. So when that happens, we're in column 1. Your ROI is severely suboptimized. But the factory applied coatings, the technology has gotten phenomenal. And your sheet vinyl with a factory applied coating should not have to be coated or waxed. It should be a never waxed floor. And when that comes to fruition, column 3 is realized and you do have the best ROI. Okay? So at the end of every module, rather than clutter every slide by keeping our promise to relate it to all the areas of outcomes, we kind of do a summary at the end of each module. So relating to clinical outcomes, operational, and business case. If you want these slides as summaries, there's a lot of words. I'm not going to go through them because it would be me reading a lot of stuff and taking too much time. And most of it's review what we've already covered. But please let me know if you'd like to have any of this information in PDF format to review at a later date. Okay, it goes again, the clinical outcomes as it relates to flooring durability should be non-porous, impermeable, compatible with sanitizing methods. So again, it goes to the no waxing, the durability, surface density, weld and seam integrity, all the things we talked about and how those relate directly to clinical outcomes. Constant innovations in equipment. You know, today's rolling MRI machine could be tomorrow's body tomography machine that has to be wheeled in with a pallet, with a steel wheeled pallet jack. So the durability of the floor relative to IAQ and everything else can absolutely affect clinical outcomes. From an operational standpoint, again, we look at best in class durability, reducing time, effort, and materials in maintenance, repair, your EVS outcomes, durability, again, relating to operational outcomes, chemical and stain resistance, less time your EVS people have to spend maintaining and cleaning stains as well as daily cleaning. We look at vendor healthcare experience as a driver of operational outcomes. If your vendor does not know the ramifications of those SkyTrine or AMSCO tables in your ORs, that can suboptimize outcomes. You know, surgery is a contact sport. Those hydraulic feet lowering and locking into that floor and that table being hip checked and orthopedic saws being dropped on the floor, what's going on in that OR is critical to the performance and those operational outcomes. And your vendor should be able to speak to those issues in terms of knowing what the ramifications of a given product and a given application are. Again, the stain resistancy, knowing all the different chemicals from your chloroprep to your benzoin and what that's going to do to the floor. If you have a vendor without the attendant healthcare experience expertise, that can suboptimize outcomes. Okay, and the business case, obviously. We always look at the first cost versus the long-term ROI, and the more data that we can provide relative to that can better inform the process. Okay, so that concludes our durability module. We're going to look at reducing complexity next. Going to look at some lean IPD things, simplifying construction processes, moisture solutions, no downtime solutions, and some further technical and maintenance. So simply in terms of your lean and IPD initiatives, I'm sure a lot of you are doing integrated project delivery and have lean initiatives. And we, as everybody else, sums that up as kind of reducing cost and complexity, taking complexity out of the process. As it's strictly defined, IPD, you're sitting in the big room at the beginning of the project, and frankly, a flooring guy is probably not in that room, manufacturer, or maybe even flooring contractor. It tends to be limited to your MEP trades, your mechanical engineering, plumbing trades, your prefab, your modular, space delivery. All those things are typically more involved in an integrated project delivery approach than necessarily flooring. But what we can say is that by involving your flooring vendor and contractor earlier and having discussions about technical things as it relates to even slab design early on, through installation training and all the other things that go into a project, the goal is the same. That spirit of IPD in your flooring projects can be adopted such that we do realize the goal of reducing cost and complexity and those 11th hour collisions being eliminated. So that's the spirit by which we speak to IPD. Whether we get to sit in the big room with you or not in the beginning and truly become part of that IPD team, that would be great, but it doesn't mean if we're not there that an IPD approach and spirit cannot be realized from a flooring standpoint. As an example of that, we look at simplifying construction processes and look at a case study. There was a large project by which a manufacturer was invited to participate as part of the IPD team early on, even before slab design was taken. So they came in, and the goal was to dry the concrete such that expensive moisture mitigation didn't have to be paid for and borne by the project. So the manufacturer came in with their technical team and devised some best practices to promote the drying of the concrete. I won't read all these to you, but it involves looking at water to cement ratio, fly ash content, all these other things, the weight of the concrete, making sure you're testing for F2170. The most controversial one was the curing method. They were used to curing compounds, so the GC and the concrete contractor kind of pushed back a little bit at this notion that a wet cover cure should be employed. That did add a little bit of complexity to their process, but the owner wanted to see this thing through. They realized the cost of full mitigation and wanted to give ourselves the best chance to avoid it, so they insisted that these be followed. And at the end of the day, expensive mitigation was avoided, and it saved the customer $2 to $3 million and streamlined the construction schedule. It's really important to note at this time that no promises or guarantees were made. Again, we don't want to gild the lily here or oversell anything. If you've got a very compressed construction schedule, if you've got a really thick slab, or if you've got weather events or conditions that aren't going to be optimal, you can do all these things right and still have to mitigate. But if you want to give yourselves the chance to not have to mitigate, by following these best practices, you're putting yourself in the best position. And it's happened a number of times where mitigation has been avoided, okay? So we dovetail on that by looking at the race to 100. What that means is that our industry has been engaged in a race to a solution that will go to 100 RH. And that's how flooring manufacturers in the industry in general gauge this whole need for moisture solutions and mitigations. If you've never seen it before, the way moisture is tested, we can talk about calcium chloride and some of the other older methods, but these days it's pretty much ASTM F2170. You sink an in situ probe into the slab and you get a reading. And that's what you're seeing in that picture. And that reading shows an RH level of 88. Most trollable glues these days go to an 85 RH limit. So if you have anything above 85, you have a conversation. 88 is not excessive. When you start getting into the 92, 95, 98, it becomes a real problem, okay? But it's all up to the manufacturer. If they say 88's a problem, you got a problem. If they say 88's okay, you're okay. It might depend on other factors. But our industry has been engaged in this race to find a solution that can go to 100 RH. And that means that the glue or the adhesive can withstand 100% relative humidity. And you see a lot of solutions, like I said, that are 92, 95. There's a lot of activity around 99 RH glues out there, and those sound really good. Hey, 99 is pretty high. It's really close to 100. Let's go with that. The problem with that is that 99 leaves a hole you could drive a truck through in terms of avoiding liability and warranty if the floor fails. And the way it works is like this. We come in, or you come in, whoever your team is, and you do a reading. And let's say that probe measured 96, okay? We've got a moisture problem. What are we gonna do? Well, we've identified a solution that goes to 99. Okay, we're good to go. Let's go ahead and install. The minute you put a non-porous, resilient floor over a high moisture slab at 96, it's trapping that moisture and it will go up from there. And what happens is if that floor blows and you have a catastrophic failure, somebody who promised a 99 RH solution will come back and you'll do your forensic analysis. You'll peel up the floor, you'll resync the probe because the hole's still in the floor, and they'll say, oh, this isn't 99 anymore, it's 100. When you see that probe and it's 100, it will read HI, the letters high, HI will show up. And they'll go, you don't have 99, ours is only good to 99, you have 100, and they'll walk away. So that's why the notion of 100 is a wonderful solution, because it eliminates all the chance for anybody who's promising 96 or 98 or 99 to weasel out if you ultimately do have a 100% moisture failure. So the goal here is that our industry's been searching for a no-limit adhesive solution for RH, pH, and MBER. The challenges have been a sole source warranty that avoids third-party additions. There's a lot of third-party solutions out there, but you get into the situation where if it fails, people are pointing fingers, and you've got 3 different players in the layer cake, 3 different warranties. The industry wants one throat to choke, for lack of a better term. It's a phrase I've heard. It means one warranty covers the whole system. Ideally, you would have a field applied adhesive with 100% capability. There are some 100 RH options out there now, but they don't check all the boxes. They might have third-party involvement. They might have product range limitations. Oh, we've got a green and a beige. Well, we can do it on the beige, but not the green. Well, what good does that do us? You might have minimum order quantities. You've got a small accent color and it's only 100 square feet. Well, no, we need 3,000 square feet to do the 100 RH solution. Or we might have massive lead times, 17-week lead times. So the ability to have a field applied adhesive that's good from 10 to 1 million square feet, no product range limitations, no minimum order quantities, and no lead times is a huge value add. And the cost should be well below mitigation, which can go for $5 to $7, or some of these other solutions that go from $2 to $3. Even infusions or topical admixtures, which have not been scientifically proven to work, can cost as much as $75 to $1.50. So the innovations in the industry now include the reality that at a cost of about 50 cents a square foot, all these boxes are checked. 100% RH, sole source warranty, no product range limitations, no minimum order quantities, and no lead time issues. So it's a real groundbreaking game changer for our industry. And you might be saying, hey, Paul, what about that big case study that you showed in the previous slide? Doesn't what you just talked about render that entire process obsolete? The answer is absolutely yes. So yeah, if we would have had this solution, the industry back when that whole best practices for drying concrete existed, they wouldn't have needed to go there, okay? So the industry also values no downtime solutions. You might have an operating room that needs to be torn down, ripped up, prepped on a Friday night after the last surgery. Floor prep is done, installation welding on Saturday, moved back in, infection control Sunday, and operating first thing Monday morning. The problem with the industry is that most troweled adhesives take 72 hours to cure. So that notion of letting a glue cure for 72 hours is rendered non-workable by the 72-hour cure time. You can't let the floor cure and be operating back on Monday morning. So we've got to have no downtime solutions that mean the glue can cure immediately and be trafficked immediately. I show a picture of an elevator cab. When people think healthcare, they don't often think elevator cabs, but it's a big pain point for a lot of facility people. They've got to be durable. They might have to go over existing subfloors, some of them which may be problematic, some which may have high moisture. They have to look good. So the notion of no downtime in elevator cabs is a value add too. So again, key considerations: operators, elevators, other occupied spaces of no downtime solutions are of value. They must be allowed to be repaired over weekends and trafficked immediately. This is another case study where a lab area in a hospital was replaced in a rolling fashion, no disruption to work. It was done after hours. The carpet tile wasn't gone over, it was replaced, but we could lift the furniture. It's a modular product. It might look like a poured or a sheet good. In looking at it, it looks so monolithic, but when you look at the picture on the left, the tabs at the top of that row where they stop for the day, you can see it. It's actually an interlocking tile that is a very durable, no downtime, loose lay solution that was perfect for this lab from a downtime solution standpoint, okay? We look at further technical solutions, core holes, weld breaks. We talked about using inferior patching materials like gypsum-based things that can break down and fail. Getting your manufacturing partner involved early to talk about these things can improve not only operational, clinical, but business outcomes to the extent that they can disrupt space and cost time and money. We look at maintenance protocols. Again, the Harvard School of Public Health talks about the health aspect of VOCs. So the clinical aspect of reducing complexity in not stripping and waxing is real, but also operationally and the business case are made huge too. I think it's safe to say that a lot of people are still stripping and waxing but from a lot of standpoints, it really makes sense to get away from stripping and waxing. It checks the boxes in terms of optimizing outcomes across the board. As a function of that, we talk about shine and glare and how that relates to all three areas of outcomes. It's been shown that a shiny floor, from a clinical standpoint, increases the incidence of slip, trip, and fall, even if the floor is not wet. From an aging population particularly, they think the floor is wet and have a higher incidence of slip, trips, and falls. Your nurses complain of more headaches with a shiny floor as opposed to a matte finish. From an operational standpoint, creating and maintaining that shine is incredibly suboptimal in terms of maybe more steps, more equipment, more cost, more full-time employee time on task. And from the business case, it's been shown that stripping and waxing is extraordinarily expensive. If you're using VCT that needs 4 to 6 coats, it must be stripped. 80% of the cost is borne by the owner after the floor is installed. It's the cheapest floor to buy, but the most expensive to own. So across all three areas of outcomes, evidence-based design strategies state that a shiny floor is suboptimal. We look at this floor on the right, it's in the same exact hospital, same exact quarter. You stand at the intersection, you look left, you see the shiny floor. You look right, you see the matte finish, and you see the contrast. That floor on the right looks clean, it looks serene, it supports patient-centered design. All you need is your typical red pad and a neutral cleaner to keep it clean. Between microfibers or your wet mops, there's no special proprietary equipment. The lack of complexity in maintaining that floor is optimized, whereas creating and maintaining that shine, chasing that shine is not as good. But I hear what you're saying. You're saying, but Paul, we like shiny floors. Shiny equals clean. It's our culture. Give us a shiny floor or you're out. So being an evidence-based design geek, I'll always try to talk you into a matte finish just because I think it's the right thing to do. And I don't think that shiny equals clean is manifested all the time if you have a floor that's durable enough to keep clean. But I'm also a guy who likes to sell floors. And if you tell me, give me shine or you're out of here, then it's incumbent upon me to give you that shine while not sub-optimizing all the other areas of outcomes. So what that looks like is this. Can we create that visual shine without adding 4 to 6 coats that need to be stripped regularly? Can we not ruin the warranties of the floor? Can we do it with minimal cost and complexity? And the answer is yes. There's been, again, innovation in the flooring industry that with just 2 coats, you can create that shine. So it's not 4 to 6 coats, it's just 2 coats that are mopped on and they scrub off over time after a year or 2. So the full stripping and waxing and all the negative ramifications of that goes away. Warranties are a big deal because of typical sheet vinyl. You would have to rough up the surface, scratch up the surface to get that wax to stick, and your warranties are then gone. So in this case, the innovation has deemed that the process can be done with all warranties remaining intact because you're not damaging the surface of the floor. Cost and complexity are optimized because you're not using proprietary products or processes that are typically outside your supply chain. And most importantly, it's reversible. Most other types of shine, whether it's just with a pad and water or with stripping and waxing, once you buy that shine, you own it. You can't reverse it. And let's say you get a new CEO in who says, no, our organizational objectives are going to go to a matte finish. And you go to your flooring guy and say, hey, reverse this shine. They'll say, we can't. Once you shine your floor, you own it. With this process, it is reversible if the organizational objectives ever change. So a lot on shine and glare there, but hopefully you can see how the outcomes from a clinical, operational, and business case are affected by these various ramifications. Okay? So I'm going to buzz through these. Like I said, we have demonstrations and citations relative to all 3 areas of outcomes. And like I said, I promise not to overstay my welcome. And the 3rd module is a little bit involved. So I don't want to race through it too fast, but I do want to get through infection control. So we'll launch right into that one. We're going to look at minimizing exposure surface contamination, some third-party ISO standards, integrated systems, and some different methods of disinfection. First off, it's important to note that going back to that durability, it's critical to your infection control initiatives because the durability of a floor makes it easier to clean and will allow your disinfectant to better do its job. The EPA, who sanctions and approves all disinfectants, has a standard by which they look at this concept called soil load. And when they test and approve a disinfectant, they have a 5% soil load limit that they look at. So what happens when the floor doesn't stay clean or isn't as easy to clean is in your hospitals, you don't have time to scrub and clean every single minute of every day. So what we find is people coming and dumping disinfectant on the floor, and you get this disinfectant dirt buildup, and you end up with this mess by which you've increased the soil load. And if the soil load is raised, the disinfectant is less able to do its job. So the moral of the story is the easier it is to keep your floor clean with a microfiber and a mop and scrub it when necessary, the more the disinfectant can do its job. So again, even though we're talking about cleanliness and infection control, it all comes back to that durability and that surface density of the floor. So this is kind of a little prequel to the module. We're going to look at some ISO standards. We're going to look at some innovations allowing floors to be easier accessed and clean, and one source integrated systems that can also optimize outcomes. It's important to note that floors are not considered a touch surface like a bed rail or a countertop, but things that come in contact, your cell phone, your call button, your blood pressure cuff can be. So it's important to note also there's no evidence of flooring being a source of an HAI, but research shows that the floor can have far-reaching impact on surface contamination in terms of spreader. So the moral of the story here is not a source, but absolutely has a potential to be a spreader. So that's where the examination has to come in. And we're looking at increased scrutiny on infection control, especially in this day and age of COVID. There's a lot of scrutiny. So it may be of value to have more advanced testing and certifications on your flooring and other finishes that allow us to better play offense if we're on defense under increased scrutiny. We'll look at some rounded floor and wall corner systems, facilitating further cleaning and disinfection. And we'll also look at integrated floor and wall systems as a feature of maximizing potential for improved outcomes. So in terms of the ISO standards, there's 22196 and there's also ISO 21702. And what these look at is a third-party ISO International Standards Organization notion that these floors have been certified to inhibit the growth of bacteria in the floor at a very high level, the maximum that the ISO standard allows, which is in excess of 99%. So you might have a manufacturer says, yeah, my floor is bacteriostatic, but it may be of value to you and the other stakeholders to know that it's been certified and by a third-party ISO as being bacteriostatic. It's important to note that it's critical to look at the difference between the terms cidal and static. Inhibiting the growth does not mean it's killing bacteria or viral activity. Then it would be virucidal, bactericidal. It's important not to oversell this. There is no floor that has a copper component like some other surfaces that can actually kill bacteria or virus. No floor will kill bacteria or virus. If somebody figures out a way to do that, frankly, it's going to be a way to print money. It'll be that much of a game breaker. But what it can do is inhibit the growth. So that's what these standards and the term bacteriostatic mean. Similarly, for viral activity, ISO 21702 exists, and that does the same thing in terms of guaranteeing that the growth of viral activity will not be promoted by the floor or other surface that's certified through 21702. So again, not virucidal, but virustatic. We look at integrated systems. It's very rare that a large, prestigious healthcare architect and design firm would call out by name a certain manufacturer or system as part of their online article. But in this case, it was actually done. This online article entitled Nooks, Crannies, Crevices, and Coronavirus Infection Control and EDs actually did call out this system, this clean corner system by name. What you see there in the picture is that corner's kind of pooched out. That clean corner, that rounded corner allows better access to the corner for cleaning, better drying, So the notion that that deeper corner where moisture and germs and bacteria sits becomes something that can harbor microbes. So from an infection control standpoint, not only this firm, but another large firm who is quoted as saying the corners of the room are rounded corners to further facilitate cleaning, really reinforce that third-party notion that rounded corners are an optimization and a best practice relative to infection control initiatives. We also look at integrated systems relative to walls and floors and how they relate to each other. What we see there is something that, again, should never happen. It's from the gallery of flooring horrors, but we've all seen it, used it, spec'd it, installed it. It's the old metal cap that you see in your integral-based installations, your flash coping. So it's in every hospital in the world, the metal cap. It's what people use. But even when it works, what we're seeing there, again, checks all the boxes of sub-optimization. It's broken down, it's failing, it could harbor microbes and bacteria, and we're all right back in our rooms sitting around trying to figure out why it happened, fixed it. So all the areas of outcomes are sub-optimized. But even when this works as it should, it's not strictly best practices, because that ledge can be a dirt catcher. It can be a place where dust and other germs settle. And certain hospitals have actually been cited when the inspector goes in and sees dust buildup on that cap. So best practices would indicate that we have a floor and a wall system that work together and eliminate all that complexity from the floor to the wall. There's no difference in the thickness. That's a picture of it in action. Here you see a blow up, a magnification. The floor and the wall are the exact same thickness, such that that complexity and that risk goes away. Not just for ORs and ERs, but we see this in compounding pharmacies. USP 800 calls for smooth, seamless, impervious finishes. We see this a lot in behavioral health, where pick-proof surfaces are really at a premium. Anti-ligature, smooth, holistic initiatives are at a premium. So not just ERs, compounding labs, ORs, but behavioral health, the wall systems are really a source of a lot of conversation these days. Again, not to oversell this, USP 800 does not mandate that you have to have the floor and the wall the same thickness. This would be a best practice. None of the things we're talking about here are CDC rules or guidelines or FGA guidelines or laws. They're things that can be implemented in a proactive approach to optimize outcomes if the stakeholder sees value in these interventions. So along that same line, hospitals aren't held to the same standard even as GMP manufacturing or clean rooms. Those are held to an ISO 3 to 4 standard. Hospitals are typically 6, 7, 8, 9, but it might be worth somebody's consideration to look at using products that are certified at a higher ISO level in this age of increased scrutiny. Okay, obviously must be hydrogen peroxide, H2O2 resistant, as well as all the other chemical disinfectants, your phenolics, your quaternary ammoniums, obviously bleach. So we get a lot of questions these days about UV light disinfection. The challenge is that UV came around at a time and it was used a lot, but it damaged some surfaces. So the discussion going around now and the ongoing testing is, can we use UVC light disinfection? It depends on duration and intensity. UVA and UVB are what gives you a sunburn and, God forbid, eventually skin cancer. UVC never reaches the surface of the earth. It's artificially produced, but it does kill. It does have those germicidal properties. So the research is whether there are UVC robots, and we're even seeing it in transportation and retail now. Does UVC work? Yes. Will it damage materials? It depends. Okay. A study was done that shows, just published in Health Facilities Management this year, that shows that it's not even a panacea. When stacked up against chemical disinfectant, relative to C. diff, it had the exact same performance. So it's not like you're going to have less HAI using UVC versus chemical disinfectant. This was done with C. diff, not COVID, but I think we all know that COVID, even though it's really tough from a contagion and the unpredictability of how it will affect from person to person standpoint, is a big deal. But in terms of a germ itself, it's not that hard to kill. We've killed Ebola, we've killed MRSA, we've killed C. diff, we've killed HIV. The complexity of the germ in terms of how to kill it with COVID is not that different. Some research in progress. It's really exciting. University of New Mexico Comprehensive Cancer Center is looking at LED bulbs. And that obviously from a cost complexity, the chance to, people can't come in contact with UVC light or they get harmed. LEDs, that's not the case. So exciting research we're monitoring, but it's pending. Nothing is set in stone there yet, so we're keeping an eye on that. Okay. So again, lots of notes, citations on our various outcomes. If you want any of those, please let me know. But in the interest, again, of not overstaying my welcome, I'm going to come back here, stop sharing my screen, start my video, and just say thank you to everybody who participated. Looks like there is some things in the chat, but I don't see any questions. So we're right up against one. I'm here. If anybody has any questions or wants to talk about anything, please let me know. I think you're muted, so either give me an email or type it in the box. But other than that, I'll let you go. And thank you so much for your time.
Sounds good. Paul, do you want to throw your email and phone number into the chat again, just so they can access that easily?
Certainly.
And I'll just take a moment to remind everyone that we've got our last town hall of the year coming up on Friday with the VCC and HDLC. And we also have our ongoing toy drive for the Louisiana Hospitality Foundation. You can check that out on our website for more information. They're picking up donations at the Hilton Riverside, down at the bottom of Canal, I believe, and you can also make a monetary donation to the website to help out those families that have been hit hard by COVID this year in the hospitality industry. And that's about all we got.
Hey, Aaron, I'm having a hard time. It just says when I type into the chat box that it's going to you privately. Is there any way you could share
that
my
drop-down menu? Are you able to change it to all panelists and attendees?
I'm not sure I can. I'm not seeing an option to do that. Oh, this drop-down menu. Nope.
Interesting.
Yeah, sorry about that. I'm sure it's my own lack of ability in Zoom.
All right. Well, if you want to send it to me privately, I can copy and share it into the broader one too.
Okay. I typed it in, but it's not even giving it an arrow to send it. This is very strange. Anyway, I'm not hard to find. Look me up on LinkedIn. Hopefully, when I did the screen at the beginning with my name and phone number and stuff, if you guys want to talk at all, please figure out a way either through AIA or myself, or one of our dealer partners, Vector Concepts, who set this up. Ashley and the gang there are easy to get in touch with. They're prevalent in the marketplace, so we'll be able to get back to you and answer any questions or help out as we're able.
Got it. All right. Thanks so much, Paul. Thanks to everyone who spent an hour with us today at lunch. Hope everyone has a good rest of their day.
Thanks so much.